At 2:14 on a Saturday morning in the Gulf of Oman, a mobile launcher concealed inside a converted freight container on a rocky promontory 11 nautical miles east of Jask rose from its horizontal storage position to a 45-degree launch elevation. The crew that operated it had been living inside two support vehicles parked 200 meters away for 6 days. They had practiced this precise sequence 41 times in the preceding 4 months, always in darkness, always against the clock, and they were good at it. From the moment the launcher hydraulics engaged to the moment the first round left the tube was 3 minutes and 17 seconds. That was their personal best. Tonight, they matched it almost exactly. At 2:17:43, an Iranian Noor anti-ship missile left the launcher on a bearing of 247 degrees magnetic and dropped to wave-skimming altitude over the Gulf of Oman. The Noor is an Iranian-produced variant of the Chinese C-802 anti-ship missile, adapted through a reverse engineering process that Iranian aerospace engineers conducted with ingenuity and considerable patience after international sanctions made the original supply chain unavailable. It flies at approximately Mach 0.9, uses active radar Hohmann in its terminal phase, and carries a warhead of approximately 165 kilograms. At wave-skimming altitude, approximately 5 to 7 meters above the surface, it is designed to defeat shipborne radar systems by hiding below their line-of-sight horizon until it is very close to its target. The target the launcher crew had designated was a large surface combatant they had identified through a spotting asset 3 hours earlier, operating approximately 47 nautical miles west-northwest of their position on a course of 312 degrees at 14 knots. The spotting asset, a small commercial-grade drone with a downward-looking camera, had recorded the ship's silhouette, its navigation light configuration, and its approximate speed. The crew's communications officer had transmitted this data to the launch authority, received authorization, and entered the target coordinates into the Noor's pre-launch programming. The missile would fly on inertial navigation until its terminal seeker activated. Simple, practiced, lethal on paper. The ship in the Noor's guidance memory was USS Fitzgerald, and here is where the story requires an honest accounting of what was happening aboard USS Fitzgerald at 2:17 on a Saturday morning, because the accounting is important, and it does not start with dominance. The Fitzgerald was in crew rotation. Specifically, the 2 o'clock watch had just relieved the 23:59 watch at the precise interval that the U.S. Navy schedule requires. 2 o'clock, sharp, and the incoming watch section was in the process of settling into their stations. The tactical action officer had just received his verbal brief from his predecessor. The petty officer on the AN/S PY-1D scope had just sat down with the scope picture his outgoing counterpart had left him. A clean Gulf of Oman, a handful of merchant traffic, no surface or air contacts of tactical significance within the designated watch area. He had acknowledged the brief. His predecessor had gone below. The watch log showed his name entered at 2:02. At 2:14, 12 minutes into the new watch, 11 minutes after the Fitzgerald's radar picture had last been formally assessed as clean, the launcher on the Jask promontory began its rise. 12 minutes. That is the vulnerability window. Not because the Fitzgerald was at trail shaft or in a maintenance cycle, or degraded in any particular technical sense. The ship was fully operational, all 4 LM-2 500 turbines online, weapon systems in standard watch condition. The vulnerability was temporal and institutional. The seam between watches is the one moment in a ship's operational cycle when collective situational awareness has a gap. The incoming watch knows what the outgoing watch told them. They do not yet know what the outgoing watch did not notice. That gap lasts in practice about 12 minutes before the new watch has read itself into the picture well enough to own it. The launcher crew had not planned to exploit this timing. They were operating on intelligence that identified the ship's position, not its watch rotation schedule. The alignment was coincidental. It was also, for approximately 7 minutes, genuinely useful to them. The Fitzgerald's AN/SPY-1D phased array radar detected the Noor launch at 2:18:09, 86 seconds after the missile left the tube. The delay was not a sensor failure. Wave-skimming missiles are designed to defeat radar horizon geometry, and at the launch range of 47 nautical miles, the Noor had approximately 33 nautical miles of wave-skimming flight ahead of it before it would enter the Fitzgerald's radar coverage cone at sufficient altitude to generate a return. The 86-second detection window was within the expected parameters for this threat class at this range. What happened in those 86 seconds aboard the Fitzgerald is worth describing, because it illustrates something important about how an incoming watch section responds when they have been in their seats for 16 minutes. The petty officer on the scope did not have a contact. He had a clean picture. The tactical action officer was reviewing the merchant traffic log. The officer of the deck on the bridge was doing a visual scan of the darkness around the ship with binoculars, a habit, not a response to anything specific. The kind of thing that experienced watch officers do because they were told to do it early in their careers and never stopped. Below decks, sailors from the outgoing watch were moving through passageways toward their berthing spaces, thinking about sleep with the focused appreciation of people who have earned it. The duty electronics technician had just finished a routine calibration check on one of the AN/SPY-1D's 4 transmit-receive modules and was filling in the maintenance log when the new watch section settled into their stations. He noted the time, 2:04, initialed the log, and went to get coffee. The coffee in the electronics maintenance space on Friday night is, by tradition and necessity, stronger than the coffee in the CIC. He poured a cup, thought briefly about whether he should go back to his rack, decided he was not quite tired enough, and went back to his bench. The radar was running clean. The Gulf of Oman was flat. Everything was exactly as it should be at 2:04 on a Saturday morning in the middle of an operational patrol. The Noor was 47 nautical miles away, 5 meters above the Gulf of Oman, closing at Mach 0.9. At 2:18:09, the AN/SPY-1D generated a contact. Not a certain contact. The first return was ambiguous. The characteristic radar cross-section of a wave skimmer at extreme range producing a return that the system's algorithms initially classified as probable rather than confirmed. The second return, 1.4 seconds later, resolved the ambiguity. Speed, altitude, bearing, and the emission signature of the Noor's active radar seeker, which had not yet activated but whose airframe configuration the SPY-1D's library recognized from the radar cross-section profile, converged into a classification. The combat system assigned a track number and a threat category simultaneously. The tactical action officer's console displayed the contact at 2:18:11, 2 seconds after detection. He read the classification, read the track data, and made the engagement decision in the time it takes most people to read a text message. He did not consult anyone. The rules of engagement were unambiguous and he knew them without needing to look them up. He keyed the engagement command at 2 hours, 18 minutes, and 19 seconds, 8 seconds from contact display to engagement authorization. The income and watch section had been at their stations for 18 minutes. The Fitzgerald had been at full combat readiness for all 18 of them. The AN/SPY-1D continued building the track as the Mark 41 vertical launch system received its firing order. The Noor was now 31 nautical miles from the Fitzgerald and closing. The engagement geometry required a response time of less than 90 seconds before the missile would enter the ship's inner defensive layer. The SM-2 Block IIIB is, among other things, a system built for exactly this timeline. Its solid fuel booster is lit, it clears the launch tube, its wings deploy, and it is on a computed intercept course in a sequence that takes considerably less time than describing it does. The first SM-2 launched at 2:18:31. The second launched at 2:18:33. A 2-second trail to provide backup coverage against a potential first-round miss or guidance failure. The Mark 99 fire control illuminator tracked the Noor continuously from launch through intercept, providing the semi-active homing guidance that the SM-2 needs to close on a wave-skimming target with a radar cross-section roughly the size of a large suitcase. Before we address the arithmetic of this engagement, the SM-2 Block IIIB deserves a moment of its own. Not a Wikipedia entry, a portrait. The Standard Missile family has been in continuous U.S. Navy service since 1967, which makes it a program of unusual longevity. And the Block IIIB is the result of 5 decades of incremental refinement applied to a fundamental design that has proven stubbornly worth refining. The Block IIIB's active radar fuse allows it to function against low-altitude sea-skimming targets, the specific category that a Noor at 5 meters altitude represents, without requiring a direct hit. The missile detects the target, computes the optimal detonation point, and the warhead's fragmentation pattern does the rest at a geometry that maximizes effectiveness against a small, fast-moving airframe at wave height. The engineering behind this capability is precise, practiced, and was validated in the 2 seconds between 2:19:47 and the moment the Noor's debris entered the Gulf of Oman. The Fitzgerald's combat system had calculated 17 different engagement options from the moment the Noor was classified as a confirmed inbound contact. SM-2 via MK-41 VLS was option 1 on the priority list. Options 2 through 6 involved the ship's other defensive layers. Options 7 through 17 involved geometries that the system computed because it computes everything, including scenarios that no rational tactical officer would have selected given the available time and geometry, because the Aegis combat system is thorough in a way that humans are not, and thoroughness is one of its defining characteristics. Option 1 was selected. Option 1 worked. Each SM-2 Block IIIB costs approximately $1,200,000. The Noor anti-ship missile costs, in Iranian production economics, somewhere between $800,000 and $1.2 million to manufacture. The cost of reverse engineering and domestic production has declined as the program has matured, but the precision components remain expensive. The Fitzgerald had just committed $2.4 million to intercept a missile that cost, at most, $1.2 million. Somewhere, a Pentagon accountant was running this math and arriving at an answer that was technically a net loss and operationally a complete victory. This is a tension that runs through every engagement in the modern era and is unlikely to be resolved anytime soon. The first SM-2 intercepted the Noor at 2:19:47, at a range of 23 nautical miles from the Fitzgerald, at an altitude of approximately 12 meters above the Gulf of Oman. The intercept was clean. The Noor's warhead did not function. The debris, approximately 460 kilograms of airframe, fuel residue, and warhead components, entered the water at a position that the Fitzgerald's combat system logged to within 50 meters. The second, SM-2, its primary target eliminated, was commanded to self-destruct at safe altitude by the combat system at 2:19:51. Total time from missile detection to intercept, 98 seconds. The tactical action officer noted the intercept in the engagement log with the tone of a professional who has just confirmed that a procedure worked as designed. He notified the commanding officer, who was on the bridge within 2 minutes. Not because the emergency required it, since the emergency was already over, but because commanding officers go to the bridge when weapons are employed, regardless of outcome. The commanding officer reviewed the engagement log, confirmed the intercept, and directed that Fifth Fleet be notified. He asked if there were any additional contacts. There were none. He asked for the crew status. Everyone was where they were supposed to be, doing what they were supposed to do. He went to the bridge wing and looked at the Gulf of Oman, which was dark and flat and empty. He stayed there for a while. Now, let us discuss the Noor itself, because it deserves a complete technical portrait before we discuss what happened to the launcher crew's operational security in the 98 seconds the missile was airborne. The Noor's design lineage traces to the C-802 through a development path that is, in technical terms, a remarkable achievement of reverse engineering under constraint. The guidance system uses inertial navigation for the mid-course phase. A gyroscope and accelerometer package that maintains the missile's pre-programmed course without requiring external input, and active radar homing in the terminal phase, when the missile's nose-mounted seeker activates and begins searching for its target. The terminal seeker is the system's critical component. It is also the system's most technically demanding component to replicate domestically, and the Iranian production process has produced seekers with known characteristics that distinguish them from the original Chinese design. The seeker on this particular Noor activated at 2:18:58, approximately 41 seconds into the missile's flight, at a range of 31 nautical miles from the Fitzgerald. Its activation was detected by the Fitzgerald's AN/SLQ-32V2 electronic warfare suite within milliseconds. The seeker's emission profile, frequency, pulse repetition interval, scan pattern, the specific characteristic Doppler signature of the Iranian-produced homing head, was recorded in complete technical detail. The Fitzgerald's EW suite had logged this seeker variant before, in previous collection events, but this recording, captured at a range and aspect angle that previous collections had not achieved, added detail to the existing characterization that analysts would find useful. The Noor had been airborne for 98 seconds. During that time, it had told the Fitzgerald's combat system and EW suite everything about itself that could be measured from the outside. The guidance package, the seeker characteristics, the flight profile, the terminal approach geometry, the radar cross-section at multiple aspect angles as the missile maneuvered toward its target. It had also, and this is the detail that the launcher crew had not considered, told the Fitzgerald something about where it came from. The Noor's inertial navigation system maintained a record of the missile's flight path from launch to seeker activation. This flight path, reconstructed from the Fitzgerald's tracking data, defined a back-azimuth, a line extending from the detection point back along the missile's track toward its origin. The back-azimuth pointed to a 12 nautical mile segment of coastline east of Jask. 11 nautical miles east of Jask is a rocky promontory. The KH-11 reconnaissance satellite that was tasked against the Gulf of Oman threat corridor as a standing collection priority had recorded a thermal anomaly consistent with a missile launch at 2:17:43 from a position on that promontory. The back-azimuth from the Fitzgerald's track data intersected the satellite's thermal anomaly position within 400 meters. The launcher crew had been located within 400 meters before the Noor's debris hit the water at 2:31, 14 minutes after the Noor launched. A pair of FA-18E Super Hornets from the Carrier Strike Group, operating 212 nautical miles southwest of the Fitzgerald, received a tasking order. They were already airborne on a scheduled combat air patrol. They carried GBU-31 JDAM precision-guided munitions. The converted freight container on the Jask promontory was a stationary target with a 400-meter position error, which is, for a JDAM with a circular error probable of 5 meters, not an error of any operational consequence. The engagement was authorized at 2:38. The first GBU-31 impacted at 2:44:17. The second impacted 11 seconds later. The converted freight container, the launcher hydraulics, the support vehicles, and the rocky promontory they had occupied for 6 days ceased to be a functional missile battery at approximately 2:44:28. The crew had departed the position at 2:21, which the U.S. was aware of and which was why the strike was authorized against the equipment rather than delayed for personnel considerations. The equipment was the priority. The equipment was neutralized. Total cost of the U.S. response: 2 SM-2 Block IIIB missiles at $2.4 million, 2 GBU-31 JDAMs at approximately $70,000 each, plus the operational costs of 2 FA-18E sorties, satellite tasking, and the engagement management overhead of an Aegis combat system doing what it was built to do. Call it $3.2 million for the full package. The Noor cost, at most, $1.2 million. The Iranian launcher, purpose-built, hydraulically elevated, maintained and rehearsed by a dedicated crew for months, cost considerably more than either. Its operational life from first launch to permanent removal from the Iranian order of battle was 26 minutes and 45 seconds. The crew had practiced their launch sequence 41 times. They got 1 live use. The cost per launch ratio for this particular program is a number that Iranian procurement planners would prefer not to calculate publicly. The Gulf of Oman at 2:50 on a Saturday morning is one of the more peculiar environments in the operational world. It is warm in the way that the Gulf is always warm. The water temperature varies by only a few degrees between seasons. The air above it carries a humidity that coats everything exposed to it within an hour, and the darkness at this hour is the kind of near-total darkness that exists 40 miles from any significant shore lighting. The Fitzgerald moved through it at 14 knots, her wake the only disturbance on a flat sea, the radar picture clean in every quadrant. 2 SM-2 launch tubes were now empty. The engagement log had 5 entries. The watch had been running for 53 minutes. On the weather deck, a second-class petty officer who had been secured from his emergency station, which he had reached in 41 seconds from his rack, barefoot, which was a personal record, stood at the aft rail and looked at the water. He had not seen the engagement. He had been below decks during the entire 98 seconds. He knew it had happened because the general alarm had brought him to his station and the all-clear had sent him back, and the watch section's tone when they passed word that the contact had been neutralized told him everything he needed to know about how it had gone. He stood at the rail for a while. The Gulf of Oman did not offer any particular reaction to what had happened in it 20 minutes earlier. It was dark and flat and moving gently in a way that had nothing to do with anything. He went back inside. Back aboard the Fitzgerald, the watch section had settled into the rhythms of a post-engagement CIC. The engagement log was being formatted for the Fifth Fleet report. The AN/SLQ-32 collection data was being packaged for the intelligence annex. The tactical action officer was on his second coffee of the watch, which was technically only his first since taking over 26 minutes ago, but the engagement had compressed time considerably. The Noor's seeker characterization data was flagged for priority forwarding. The petty officer on the scope was watching a merchant vessel make 18 knots toward Muscat. The Gulf of Oman was quiet. At 2:57, the commanding officer came back down from the bridge wing. He stopped at the tactical action officer's console and reviewed the engagement summary. Detection to intercept, 98 seconds. Back-azimuth to launcher position generated within 3 minutes of intercept. Launcher neutralized at 2:44. He read the timeline without comment. Then he asked the tactical action officer how his watch was going. The tactical action officer said it was going fine, sir. The commanding officer said that was good. He asked if the coffee in the CIC was any better than yesterday's. The tactical action officer said it was about the same. The commanding officer nodded, said to carry on, and went to his sea cabin. By dawn, Iranian state media had broadcast a statement claiming that the IRGCN had conducted a successful engagement operation against American naval forces in the Gulf of Oman. The statement described the operation as proof of Iran's capability and resolve to defend its maritime rights. The Noor launch was described as a precision engagement demonstrating advanced Iranian missile technology. The statement did not mention the SM-2 Intercept. It did not mention the GBU-31 strikes on the launcher position. It did not mention the 26 minutes and 45 seconds of operational life that the launcher and its carefully rehearsed crew had spent in active service. The statement was technically accurate in every particular that it addressed, which were few, and silent on every particular that mattered, which were many. The Fitzgerald's engagement report, the intelligence annex with the Noor seeker characterization, and the battle damage assessment of the launcher position were all in Fifth Fleet's inbox by 6 o'clock. The intelligence product from the Noor's 98 seconds of flight, seeker variant characterization, flight profile data, back-azimuth methodology for launcher attribution, would be incorporated into the updated threat library and distributed to every U.S. Navy surface combatant in the 5th and 7th Fleet areas of operations. The next Noor would be tracked from a slightly better baseline. The next launcher would be found slightly faster. 41 practice runs, 1 live attempt, 26 minutes and 45 seconds. The Gulf of Oman, at first light, was completely unremarkable. Bye for now.